All right, so we've solved for the final angular speed. In order to, why is this spinning trick have to work? For that to work, you have to have angular momentum to start, right? Because we know initial momentum will equal final momentum as long as there's no outside torque. So if you're originally not rotating at all, your angular momentum is zero. So then your final angular momentum will also be zero. So in order for this to work, you have to be spinning at least for a little bit in the beginning. Okay. All right. So we're going to continue on to the next part of this, which is looking at what happens when someone is in a chair and they catch the ball. So you have three options. You can throw the ball right at them in the center, a little bit to one side, or a lot to one side. Now, if I throw the ball at you at the center, when you catch it or when it hits you, you're not going to move at all. You're just going to sit there, okay? Partially because it's coming at you at the axis of rotation. If you hit right here, a little bit over, it's going to cause you to rotate a little bit because torque is equal to Fr, the force from the ball times the distance from your axis of rotation. But if you throw it all the way out to my hand, I'm going to scoot this way so you can see, then this is going to cause a much larger torque because your R from the axis of rotation is much bigger. So torque equals F times R. That force is going to cause the greatest amount of torque. If I cause the greatest amount of torque, I'm going to cause the greatest angular acceleration, which also means I have the greatest angular velocity. Okay, so let's think about this in terms of momentum. Okay. Let's talk about the system, right? So in momentum, we always talk about everything is in the system so that there's no outside force, there's no outside torque. Okay, so let's think about what that would mean. If I threw the ball at the person, but the ball wasn't in the system. If the ball wasn't in the system, the question is, how can this ranking be true if the ball is thrown at the exact same speed at every single spot, right? Regardless if I throw it at the center, to the right, or all the way out to the right, how can one cause a larger angular velocity than the other? And because the ball is not in the system, we are giving an outside torque. And because we want the greatest outside torque, if the further away you hit, the more torque you're going to cause. Okay. Then let's think about the system that does contain the ball. So how can we talk about the ball how is it true that this ranking exists if the ball is thrown with the same speed at the same time? Okay, so now my system is the ball. Okay, so if the system is the ball, we know that angular momentum is going to be conserved. So angular momentum before must be equal to angular momentum after. So let's focus on the after. If I catch the ball, I am going to get some sort of angular speed, which is angular momentum, right? It's I times omega. So I definitely have some final angular momentum. If I have final angular momentum, then that means I must have had some initial angular momentum. Okay. Now this is confusing because the ball is being thrown straight at the person, causing an angular momentum. But for that to happen, according to physics, we know that angular momentum has to be, there must be an initial angular momentum before the ball hit him. So the question is, how can something moving in a straight line have angular momentum? Well, it's because in order for something to be conserved, and as long as there's no outside torque, which everything was in the system, then L initial has to be equal to L final. So it's kind of crazy that something that's moving in a straight line can have angular momentum. All right, we're on the last slide. How can the ball be thrown so the person catches it, but the ball transfers no angular momentum, right? So there's a couple ways that we've talked about. We know that to get the most amount of angular momentum, we're going to throw it all the way to the outside, causing lots of angular speed. But now let's talk about how can I throw it, right? Before we were talking about just throw it straight at them. We could also throw it on an angle, or we could also throw it parallel to where the person is. So when you throw it parallel to where the person is, if I catch it and the ball's coming at me right here, that's not going to cause any angular momentum at all. So that wraps up the notes. Stay tuned as we're going to introduce a couple questions on worksheet number 13. Thanks, guys.